Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 7.5 and it's about counting permutations and combinations. And I will talk in this video about fundamental counting principle. The fundamental counting principle says if we have an event A and the number of ways that this event A can occur is denoted by n of A, and we need to do this event will happen, and then after that event a second event b will occur, and the number of ways that this event can occur is denoted by n of b. Then the two events can occur in n of a times n of b ways. So notice that there are two events to occur, the first one and then the second one. So if these two events should be occur, then the number of ways would be n of a times n of b. For example, uh, the total number of possible meals at the restaurant here. Yeah, let us take this example first. Suppose that you decide to dine at a restaurant that offers 3 appetizers and 8 entries and 6 desserts. So to eat a meal in this restaurant, you will choose one of 3 appetizers, then one of 8 entries, then one of 6 desserts. So these are 3 events to occur. The first one, appetizers. You can choose appetizers in how many ways? In 3 ways. 3 different appetizers are available. 8 entries, one of them you will choose. 6 desserts. So in how many different meals are possible? How many different meals can you have? So the fundamental counting principle can be used here, and the number of meals, different meals, would be 3 times 8 times 6. 3 appetizers times 8 enters times 6 desserts, and there will be 144 different meals. So for example, uh, the first choice could be an appetizer, and I can choose appetizer 1 or appetizer 2 or appetizer 3. This could be your first choice, one of the 3 appetizers. And then for each appetizers, for example, if you choose the first appetizer, you have now 8 possible choices for the entries. Entry A1, entry 2, entry 3, and so on, up to entry 8. And if you choose the first appetizers and the first entry, then you still have 6 desserts to choose from. Dessert 1, dessert 2, dessert 3. So as you can see, one of the choices, the first meal could be A1, E1, D1. The second meal A1, E1, D2, and so on. So you have 144 different meals. So we use the fundamental counting principle in such cases. Okay. Pennsylvania offers a special Save Wild Animals license plate, which gives Pennsylvania zoos $15 for each plate sold. These plates have the two letters P and Z. So first, in the first position, uh, the two letters P and Z are there. Then they followed by 4 numbers. These are the 4 numbers. When plates like these have all been purchased, when they finish PZ followed by 4 numbers, additional plates will replace the final digits when a letter other with a letter other than O. So they will sell the same additional plates with PZ 3 zeros, three numbers, but then the last digit would be a letter, but other than O. What is the maximum amount that zoos could receive for the sale of the plates? Well, let us understand the question and answer it step by step, because the fundamental principle, counting principle, goes step by step, event A, then event B, and so on. So first, P and Z are there. The two letters are always there. So we have choices with these four digits, four numbers. So for the first digit, how many choices are possible? Okay, four numbers. How many number you can put here in the first digit? Well, I have from 0 to 9. I can put from 0 to 9. So I have 10 different possibilities to choose from. What about the second number now? The second event, 10 possibilities. The third event, the third number, 10 possibilities. Now the last digit, the final digit, I will put first a number, so I have 10 choices. But then after, uh, I will make additional plates with the letter also here. So the possibilities here would be 10 digits plus 26 letters, but O is not there. So I'll have 25 letters. So the possibilities for the last digit is 35. So the number of plates would be 10 to the power 3 times 35. These are the number of different plates the zoo can make. The question, what is the maximum amount that the zoos could receive? Well, they sell each one for $15, so the maximum amount would be $15 times the number of plates, of possible plates. Please use your calculator always to find the final answer. So here, that's the way to solve the question, step by step. Think about it, read it carefully, and then do it step by step. You have to understand the question carefully before trying to solve it, okay? If a state permits either a letter, or a non-zero digit. Non-zero digit, so the number of digits would be 9 digits, not 10, because the zero is not there. And the number of letters is 26. To be used in each of 6 places on its license plates. How many different plates can it issue? So there are 6 places. Okay, 6 places. And the zoo, sorry, there is the state here. The state permits either a letter or a non-zero digit. So in the first place, what are the possibilities? Either a letter or a non-zero digit. So you can put here in the first place a letter or a non-zero digit. How many letters and non-zero digits are possible? 26 plus 9. That's 35. So I can choose the first place among 35 possibilities. Okay, how many places are there? 6. What about the second place? Also, I have 35 possibilities, and so on. So how many different plates can it issue? It can issue 35 to the power 6. 35 times 35 times 35, 6 places. This is the fundamental counting principle. You multiply because I need the 6 places. This place, then this place, then this place, then this place. So 35, the number of ways that each place can occur, and you multiply all of them together. That's the fundamental counting principle. A state wants each of its license plates to contain 7 digits. How many different license plates can it make? Okay, now the license plates contain 7 digits. So 7 digits, 1, 2, 3, and so on, 7 digits. What is the question? How many different license plates can it make if all the digits are different? Okay, digits means numbers. Each of its license to contain 7 digits. We have 10 digits from 0 to 9. These are 10 digits. So in the first place, I can choose one of the 10 digits. All the digits are different. If all the digits are different, then in the second place now, if I choose, for example, 8 in the first digit, I cannot choose again 8. Well, yeah, I cannot choose 8 because all the digits should be different. So this digit, the second digit, cannot be 8 because all the digits are different. Okay, so here I have 9 possibilities, and then 8 possibilities, then 7, then 6, 7 digits, 1, 2, 3, 4, 5, 6, 7. So up to 4, 2, 4, 6, 7. So the answer would be 10 times 9 times 8 times 7 times 6 times 5 times 4. And this is using the fundamental counting principle. And the answer would be 604, 800 different plates in this case. Well, what if any 7 digits may be used? Any 7 digits may be used, so they could be equal. 8, 8, 2 digits could be equal, 3 digits could be equal. Any 7 digits can be used. So here in this case, the first choice, I'll have 10 numbers to choose from, the second 10, the third 10, and so on. And there are 7 digits. So the answer would be 10 to the power 7. Suppose a person planning a banquet cannot decide how to seat 6 honored guests at the head table. So there is a head table, there is a table, a head table, and he cannot decide how to seat these 6 honored guests. In how many arrangements can they be seated in the 6 chairs on one side of a table? Okay, if we have 6 chairs, then let us think step by step. The first chair. Now, let us seat one of them in the first chair. How many possibilities are there? We have 6 honored guests. So any of the 6 could be set here in the first chair. In the second chair, only 5 because one of them has already been seated. Then 4, then 3, then 2, and the last one will sit in the last chair. So these are the number of arrangements. 6 times 4 times 5 up to 1. And if you multiply these numbers, you will get 720. So there are 720 arrangements. A department store manager wants to display 6 brands of a product along one shelf of an aisle. So this is shelf, okay, one shelf of an aisle, and we have 6 brands, and he wants to display all of them. In how many ways can he arrange the brands? So let us do it step by step. First one, let us display one of them. How many possibilities are there? We have 6 brands. We can put any of the 6 here. Then 5, then 4, then 3, then 2, then 1. So this is similar, exactly similar to the previous question. How many ways can a 10 question true false test be answered? Okay. How many questions are there? 10 questions. Let us do it a question by question. You have to think always step by step. So let us answer the first question. What is the first question? True and false. So how many possibilities are there? I have 2 possibilities to answer, either true or false. And then the second question, 2 possibilities. The third question, 2 possibilities. How many questions? 10. So there are 2 to the power 10 possibilities to answer these 10 questions. Now, let us talk about this symbol n factorial. This is called n factorial. Okay. What is the definition of n factorial? It is n times n minus 1 times n minus 2 times n minus 3 times n minus 4 until you reach 3 to 1. So, for example, this is actually is 6 factorial because it's 6 times 5 times 4 up to 1. So this is 6 factorial. It is in the calculator. So if you press 6 factorial, it is above x to the power negative 1. If you ask 6 factorial, you will get immediately 720. So that's what we mean by n factorial. 0 factorial is 1 by definition. Okay, so 0 factorial is 1. 1 factorial is 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 2, 3 times 2 times 1, which is 6. 4 factorial would be 4 times 3 factorial. So it would be 4 times 6 times 24. So notice this fact that I can write 4 factorial as 4 times 3 times 2 times 1 or 4 times 3 factorial. That's important. So for example here, n plus 1 factorial, the definition is n plus 1, okay, the first number, 4 first, times I subtract 1. If I subtract 1 from n plus 1, I'll have n. Then times n minus 1, n minus 2. But I can stop at any time and write factorial. So in fact, n plus 1 factorial is n plus 1 times n factorial. Why I wrote it like this? Because I can cancel n factorial with n factorial, and the answer would be n plus 1. What about this one? Well, 2n plus 2 factorial is 2n plus 2. Subtract 1, 2n plus 1. Subtract 1, 2n. Subtract 1, 2n minus 1. Subtract 1, 2n minus 2, and so on. At any time, you can stop and put factorial. But I'll stop here and put factorial here. And why is that? Because I see that in the denominator, I have 2n factorial. So I can cancel 2n factorial with 2n factorial, and this would be the answer, 2n plus 2 times 2n plus 1. If you want, you can multiply, expand them. So I'll have 4n squared, 4n plus 2n is 6n, and 1 times 2 is 2. So this is the answer. Here, kind of equation, find n, okay? Yeah, what is n plus 1 factorial? It is n plus 1 times n factorial. And this is equal to 17 n factorial. Well, I can divide now by n factorial. I can divide both sides by n factorial. So n plus 1 would be 17, or n is 17 minus 1, which is 16. Also here, uh, n plus 1, I can immediately divide by n minus 1 factorial. So I'll have n plus 1 factorial over n minus 1 factorial is 30. And what is n plus 1 factorial? It is n plus 1 times n minus 1. And now I'll put factorial because I have n minus 1 factorial in the denominator. If I expand this, I'll have n squared plus n. If I take 30 to the other side, so I'll have this quadratic equation, and I can solve this equation by factoring n plus 6 times n minus 5 is 0. Now 6 minus 5 is 1. So either n is negative 6 or n is 5. So there are two answers for this problem. But can n be negative 6? Well, if n is negative 6, then I'll have negative 5 factorial. And actually, we don't have negative factorial because if you notice here, n is a positive integer. So there is nothing called negative 2 factorial. Factorial is not defined for the negative numbers, all right? So negative 6 here is rejected because n cannot be negative. Then the only possible answer is 5. Banquet seating, how many seats are there? 1, 2, 3, 4, 5, 6. Suppose the planar in example 2 knows that this here, if you, do you remember this example? This example, yeah, 6 honored guests seated on the table with 6 chairs. But now he has 8 people. 8 people think they should be at the head table, but only 6 spaces, 6 chairs are available. How many arrangements can be made that place 6 of the 8 people at the head table? Now we will do the same, but uh, let us think step by step. In the first chair, how many possibilities are there now? We have 8 people, so any of these 8 can sit, and then 7, and then 6, and then 5, and then 4. 2, 4, 5. The last seat would have 3 possibilities. So the answer is 8 times 7 times 6 times 5 times 4 times 3. So we are using the fundamental counting principle, although we will know in the next video that this is also a permutation, okay? And you can write the answer. All right. How many 4 digits, how many 4 digits numbers, how many 4 digit numbers can be formed from the digits? Okay, so these are the possible digits we can choose from, not from 0 to 9, from 1, only 1, 3, 5, 7, 8, and 9, 2, 4, 6. 6 possibilities. And how many now how many digits are there? 4 digits. So we have 4 digits only. 1, 2, 3, 4, and 6 numbers to choose from. How many 4-digit numbers can be formed if each digit may be used once in each number? So how many choices are there here? 6. Now, each digit may be used once. So if you use any one of these 6 digits here, you cannot use it here. So how many possibilities now in the second digit? You have only 5 possibilities. And now you have 4, and now you have 3. So the answer is 6 times 5 times 4 times 3. And if you multiply, this is 360. If each digit may be used repeatedly in each number, so no problem, you can use any of the 6 digits repeatedly. So in this case, there are 6 possibilities always available because I can put any of these 6 digits. So the answer is 6 to the power 4. The call letters for radio station begin with K or W. So either K or W. So how many choices for the first letter? 2, K or W, followed by 3 additional letters. 1, 2, 3. 3 additional letters. How many choices here? 26. How many sets of call letters having 4 letters are possible? And here, how many possibilities? 26. How many possibilities? 26. So it's 2 times 26 to the power 3. These are the number of sets of letters. How many ways can a 10 question? Let us answer question by question. Okay. Question 1. What kind of question? Multiple choice test. How many choices are there? 4 possible answers. Answered if each question has 4 possible answers. So let us answer the first question. How many possibilities do you have? 4. You can choose any of them. So you have 4 possibilities. Go to the second question. How many possibilities? The third question. How many possibilities? How many questions are there? 10. So 4 to the power 10 would be the number of ways we can answer this set of questions. The last question about the fundamental counting principle. South Ca- Carolina previously had license plates containing two letters followed by four digits. Okay, two letters and four digits. But now has plates, okay, they change it to plates with three letters and followed by three digits. How many more plates are now available? Okay. How many possible plates are here in the old system? Well, two letters. Choose a number in the first place, 26 possibilities. Another letter, 26, but four digits. So 10 times 10, 4. Okay. But here, three letters. So 26 in the first position, 26 in the second, in the third, and then three digits. So 10 times 10 times 10, three times. So the answer would be 26 to the power 3 times 10 to the power 3 minus 26 to the power 2 times 10 to the power 4. And you can use your calculator and find the difference between these two uh, number of plates. The difference is 1 million. Wow. 1 million 80. Is it 1 million even? 10 million. 10,816,000. That's a big difference just because they let one position changed it from a digit to a letter. Thank you very much, and I will continue in another video.